Hey everyone, so the title for today's notes is solving logarithmic equations. Okay, wait, there's someone at my door. See, this is the issues of doing it here. One second. Hi. Okay, cool, thank you. Okay, sorry. What was I gonna say? My iPad's only at 8%, guys, and the bell's gonna ring in 17 minutes, so we gotta get this done really quick. Okay, so solving logarithmic equations. So last time we talked about logarithmic expressions. That was these over here. These were all considered logarithmic, sorry, not these. These are logarithmic expressions that we went ahead and simplified. We either simplified them through the process of condensing or through the process of expanding. And then we used our properties, the product, the quotient, and the power property to condense them either into a single logarithm or expand them out. So today we're going to be working with logarithmic equations. Now, there are two types. There's the type whenever you have a log set equal to a log, and then there's the type that you have a log set equal to a number, and then the steps to solving those are differently. So I will go ahead and do about 2 questions from type 1, and then I'll do 2 from type 2, and then you all will be expected to, actually I won't have you guys do the rest for homework since this lesson is a quick one. Just do the ones that I do in the video, and then tomorrow in class on Tuesday, I'll give you guys some in-class time to work on the ones that we don't finish here. Okay, so type 1, whenever you have a log set equal to a log. So the 3 simple steps. First step, you're going to condense each logarithm. That's why you need to have understood condensing really well. Number 2, you're going to use the one-to-one property, which tells you this. If the log of base b of m is equal to log base b of n, then by rule, you can go ahead and set m equal to n. It kind of goes back to, again, when we were working with equations, when we had like 2 exponential terms, like if I had 3 to the power of x is set equal to 3 to the power of 7, then because the bases were the same, I could set the exponents equal to each other. That's the similar idea here, right? If I have log base b of m is equal to log base b of n, then by the one-to-one property, you know that m and n must be equal to each other. Once you have solved that, after you've set the 2 m and n equal to each other, then you're just going to solve it and check for extraneous solutions. So I will go ahead and do 1 for you all, and then or maybe 2 for you guys, and then you'll be expected to do the rest tomorrow in class. So like, for example, number 1, we have log base 5 of 5x plus 9 set equal to log base 5 of 6x. These 2 terms, they both have a log, they both have the common base. So by definition, we can just set 5x plus 9 equal to 6x, and then go ahead and just solve this one for x by subtracting 5x to both sides, and then you get 9 is equal to x. So your value of x is equal to 9. You do need to check it. The way that you check it is by substituting it back in to the original equation here and here for x, and then you should verify that you get 2 sides that are the same. In this case, you do. So this one is a working solution. All right, let's go ahead and do another one. So, for example, oh, and by the way, the only thing that you need to check for when you solve is that you do not get the log of a negative number. So in this case, because you do not get the log of a negative number right when you substitute it in right here for x and right here for x, then you know that it's a true solution. Let's try another one here. Let's do number 6. So in number 6, this is not log set equal to log just yet, because on the left-hand side, you actually have 2 separate logs. You have a log here and a log here. So what you're going to go ahead and do is, like step 1 says, you're going to condense this side first, have it as a single log set equal to a single log, and then you can use your one-to-one property. So how do I go ahead and condense this? Well, I know that I have log base 4 of 68 minus log base 4 of 4. These 2 terms terms. They both have a log, they both have a common base, they're being subtracted. So we can use our quotient property to write this as log base 4 of 68 divided by 4 is equal to log base 4 of 3n plus 11. What is 68 divided by 4? Well, that goes ahead and gives you 17. So you get log base 4 of 17 is equal to log base 4 of 3n plus 1. This is now a one-to-one where you have a log set equal to a log. They have the same base, so you can just set 17 equal to 3n plus 1. Solve this for n. You end up getting subtract 1, so you get 16 is equal to 3n. Sorry. There should have been an 11. I put a 1, 11. You end up getting 6. Oh my gosh, I'm stressing because I don't want my iPad to die. So then you get n is equal to 2. Make sure that you check it. And in this case, whenever you substitute in your value of n right here, you end up getting a positive log. So this one works. Okay, I'm trying to think here which one will also probably be difficult for you guys. Probably number 5, maybe, because you see a fraction. Let me go ahead and work that one out for you. Number 5. Sorry, JK, 7. Let's go ahead and condense the left side first. So I see this coefficient here. I'm going to go ahead and use my power property to take this coefficient and add it there. So this will be the log base 6 of 25 to the 1/2 power. 25 to the 1/2 power. Remember, that is the same thing as the square root of 25, which is 5. So you get log base 6 of 5 is equal to log base 6 of 23 minus 4w. This is now a log set equal to a log, so you can go ahead and just set the 5 equal to the 23 minus 4w and solve for w. You end up getting for this one negative 18 is equal to negative 4w, so w is set equal to a positive 9/2. When you substitute this one in, it also works. Okay, so that's type 1, log set equal to a log. Hopefully they make sense. If you have any questions, make sure that you ask me on Tuesday. Like I said, you do not have to finish the extra ones. We will go ahead and I'll give you in class time on Tuesday to do that. Okay, let's try the back ones wherever we have a log set equal to a number. So this is type 2. This is not log set equal to log. This is a logarithm set equal to a number. So the 3 steps for these ones are, number 1, condense and isolate the log. So what does that mean? Again, you're going to condense them. So like if you notice that there are some properties that you can use to write this as a single log, you're going to go ahead and do that. And isolate it, it means to get it on one side of the equal sign. And then you're just going to write the log in exponential form. So knowing how to convert from log to exponential form will be used today, which is what we did on that first day. And then again, you're just going to solve and check your solutions. So I'm going to go ahead and do 2 of these for you all, maybe 3. I don't know. We'll see how we do on time. So number 11, it says to follow the steps. First, you condense and isolate. In this case, is this condensed? It is, because we only have the word log written once. Is it isolated? Is it on one side of the equal sign? It is. So this one, we can skip step 1 and go straight into step 2, which tells us to write the equation in exponential form. How do you write a log in exponential form? Well, remember, you take the base, you set it equal to this, you take the base, you raise it to the power of 6, and then you set it equal to this. So this will be 2 to the 6 set equal to x minus 4. Now at this point, you just evaluate this. What is 2 to the 6? Well, that is 64 is set equal to x minus 4. Solve for x. You get x is equal to 68. When you go ahead and substitute that 68 that we just got right here into our original equation, you get the log base 2 of 68 minus 4, which is 64. 64 is a positive number. So this one is a true and working solution. Let's go ahead and try another one. Maybe number Like in number 12, the first thing that you would need to do here is it is condensed because we only have one log. However, it's not isolated. So like I would first want to go ahead and put plus 7 here. Move that to the other side. So you get log base 3 of 4x plus 8 is set equal to 4. And then now this is like the first one where you can go ahead and just turn it into exponential form and solve. What other one might be a little tricky here? Like let's go ahead and do number 15, because number 15 you're going to get a quadratic and that might throw some of you all off. So for number 15 you're going to see here that it is not condensed because I have a log here and I have a log here. So what I'm going to go ahead and do is write this as a single log by putting log base 6 of these two logs are being added together. So what do I do with the x plus 9 and the x? I go ahead and multiply them. So it'll be x plus 9 times x set equal to 2. Here go ahead and distribute out that x, so it'll be log base 6 of x squared plus 9x is equal to 2. Again, all I did right there was distribute out the x here and here. And then now this is a log set equal to a number, so I can go ahead and convert this into exponential form by writing this raised to the power of this set equal to this. So this will be 6 squared set equal to x squared plus 9x. Just evaluate this. This will be 36 is set equal to x squared plus 9x. This is now a quadratic, which you all should recognize here. It can, in order to solve a quadratic, you want to set it equal to 0, and then you can either use factoring or the quadratic formula. In this situation, you will notice that factoring works, so it'll be x squared plus 9x minus 36, right? Because I'm going to move this minus 36 to both sides is set equal to 0. So this is a quadratic set equal to 0. You can factor it. You put a times c at the top, b at the bottom. My a value is 1, my b value is 9, my c value is negative 36. So at the top I put negative 36, at the bottom I put 9. The two numbers that have a product of negative 36 and a sum of 9 are positive 12 and negative 3. So I'm going to rewrite this as x plus 12 and x minus 3 set equal to 0. Because my a value was 1, I don't have to do any division of a. I can just use a zero product rule to solve these. So x plus 12 equal to 0 and then x minus 3 equal to 0. Remember, the zero product rule tells us that we can set this equal to 0 and then this equal to 0 and solve. So what are the two values of x that I get? Well, I get x is equal to negative 12 and x is equal to a positive 3. I go ahead and get two solutions here. Now, this is where checking your solutions is super important, because in this situation, if I were to substitute in a negative 12 right here for x, negative 12 plus 9 is negative 3. Can you take log base 6 of negative 3? No, because you can never take the log of a negative number. So this solution right here is not a solution. It is what we call an extraneous solution. However, if I were to substitute in a 3 right here and right here, obviously 3 plus 9 is a positive 12, and then right here would just be a 3. So this is my only true solution for this logarithm. Negative 12 is not a true solution because it gives you a negative of in the log. You cannot take the log of a negative number. Alrighty, I think that is it. If you all need help on any of these, make sure that you ask. So these are the two types of logarithmic equations, either ones where you have a log set equal to a log and then you just condense, use the one-to-one property and solve, or type 2 where you have a log set equal to a number. For that one, you condense and isolate and then you solve, convert into exponential form and then you solve. All right, when we come in class tomorrow on Tuesday, March 7th, we will practice the rest of these questions in class time and then do some other activity practicing this some more. If you have any questions, let me know. Thank you.